Okay,
So
so
we shall
I just want to say hello again, everyone. Nice to see you here again. Today we are going to continue the cloud native series with our host today, Bashir. Uh, the first webinar covered DevOps. Now we are covering Kubernetes, and we will arrange the third session as well. We haven't decided the time for that, so we will announce it in the community as always, okay, for the third part of the series. So I think that most of you already know our host today. He is one of our top webinar hosts in the community. He is also one of our top elite users in the community. So he's one of our most trustworthy and appreciated webinar hosts. Always a pleasure to work with him. So now I will let you, Bashir, take over. I just want to mention that we will keep the microphones muted during your presentation just to avoid any noise during your presentation. But our participants can, of course, use the chat option if they have any questions or if anything is unclear. And we will also have a live Q&A session where Bashir will answer some of your questions. If time does not allow it, you can also post your questions in the community, and he and our moderators will check your questions a bit later. I will kindly ask you to keep your questions relevant. Okay, so please make sure that your questions are related to today's topic. This is very important because, as I said, we have limited time, so we cannot answer too many questions during the live session. And as always, we will also have an activity where you are welcome to answer 3 questions based on the content that was presented today. You can win 600 high coins, and also the 3 best questions that are related to today's topic will be selected by our host today and rewarded with high coins as well. I will share the link where you are invited to go and answer the questions and also post your questions. I will refer to it as the webinar post. Bashir will also mention it probably. So the webinar post is the post that I will share in the chat. You will see it, and you will be able to also find the recording of today's session uploaded in this post as well. So everything that is related to today's session will be in that post. Okay, just to make sure that it's not difficult for you to find information or to participate in the activity. So I shared the link now in the chat. I think everyone can see it. So this is the webinar post in the chat. And okay, Bashir, I will let you take over now. Thank you.
Thank you, Ms. Alina, and welcome you all again to the Going Cloud Native with DevOps and Kubernetes series. That is our second part. First, we had DevOps. So the first part was more about DevOps, and this is our second part. So we'll start with the second part. Before going that, we'll see what is our journey and what we are going to achieve. The first part we will be having was about DevOps. That is essential for any cloud native deployments. Then today we will be having Kubernetes design, because we will be start exploring what is the world of Kubernetes and how do we use it and how Huawei Cloud is supporting us. And then in the third part, we will be seeing how to develop these applications with the use of Huawei Cloud and DevOps tools. We may add another part for Kubernetes if required, or any other topic which needs your attention. But right now, this is our path to follow, because this is a journey comprises of different technologies, different tool sets. So we try to cover as much as possible. So what you will going to learn today, that is very important. The first thing is Kubernetes. We will try to learn more about Kubernetes, its benefit, its architecture, its component, and also start deploying Kubernetes on Huawei cloud as well. And then we'll be using different tools of Huawei cloud to build some application and try to demonstrate some output over it. And then we have a live Q&A session as always, and a quiz, and also some sort of a reward in the end. But I'll try to answer every question, but try to be specific, as Ms. Alina suggested, that regarding the topic, if you have any other question, you may ask over the forum. I'll be happy to answer. That's not the issue. But as the webinar is very dedicated time, specific time, so we need to be very specific with our content. So that was a quick request. And then definitely the more about Kubernetes, it's the theoretical part and the practical part as well. So for those who don't know me or yet to know me, so it's a quick description about myself, what I do. You can follow me on LinkedIn, on the forum. I'll share the link of my profile, or Miss Alina, if you can share my profile in a chat, so that would be a great thing.
Yes, sure.
So thank you. So I have conducted many webinars at Huawei forum and different forums as well. This is my 7th one, and specifically the second in this year. So these are some certifications and details. But right now we are starting our journey of cloud native. So before that, I'll ask you, what do you think cloud native is? You can just write a single sentence on the chat. I don't need any big definition or some thesis like project. It's just simple definition. What do you think by the cloud native? Because we have been following this topic for a month or so. We had one webinar at 23rd March, and that is the second part today, 24th April. So the world of cloud native comprises of 4 basic ingredients, you can say: DevOps, containerization, CI/CD, and the microservices. First, we had a detailed discussion on DevOps, what DevOps do, how it helps us, and everything all about. In the second part, we'll be more focusing on containerization, or you can say the controlling of containerization, that is called orchestration. Definitely, this microservices will be using container, and containers are being managed by Kubernetes. That is our topic. But before going that, let me take you to some history point. Like 20, 30 years ago, we had different approaches. You are having for development cycle, we had servers, we had data center. But as the time progresses, we move to DevOps, we move to microservices, where all the architecture is divided into a smaller part, and then the physical servers are no more widely used. We use containerization, and we move to the cloud. So that after 2010, the scenario is entirely changed. For that part, we need some services, some tools, some you can say softwares to manage, and then all that operation which is being performed over is being done by the Kubernetes, because there are multiple of containers, and then all these containers are managed by Kubernetes. It's a quick introduction, but let me tell you in detail in upcoming slides. As I mentioned, there are 4 parts, basic parts of cloud native: microservices. It's been dividing whole bunch of software cycle into a smaller part. And these microservices are being used by the container. Every service, every software, smaller part is hosted in a container. And then we have multiple of containers. How do we manage these? This is the topic which we are looking for today. But before going to that detail, I'll try to ask you about the container. The container is a generic English word which we always heard in different parts of the world. But container in computer or in the IT world is something, a computing resource, a short computing resource, which has shared CPU and memory with the host. So for example, I have a laptop, I can have multiple of containers available, and all these containers are small tiny computers. So maybe in my laptop, I am running 100 containers. In one container, I am running my web server, and in second container, I'm running my video conferencing server. In third part, I'm storing some data, and then list goes on. But what if I have thousands and millions of them? Then the problem comes in, and that problem will be solved by something which we are going to discuss today. But before that, the container is very versatile thing. You can run any services, and you can run container on any platform. This one page picture is, you can say, a bird eye view of the world of container. You can run container on your servers, your laptops, your desktops, your machines, your public cloud, even on your Raspberry Pi. So the container can run anywhere. It's a small computing resources, and you can run anything, a website or an email server, anything you can. But the most of things can be run on a container. But what's the issue? When we have millions and billions of containers, and the Google is running 2 billion containers per week. That's been 8 billion containers per month. That is the population of our whole world. It's been one container for one people in the whole universe. But definitely these values can be changed, and these values are very dynamic. But just to give you an idea, so now you have a problem in your mind, like 2 billion containers, how they are going to be managed? Who is going to manage these containers? Definitely these all 2 billion containers are not running at certain location. It is divided into certain locations. They are divided over the period of time, everything. But still, the quantity is very, very high. Even if I'm running a container for my small office, maybe there are like hundreds, or maybe sometimes it's thousands. So it's not humanly possible to manage, operate, or you can say even build that containers. So we need some software, that is Kubernetes, or you can say container orchestration system. Orchestration is the word of an English. It's a little difficult word to pronounce, but it's a very good word. What container orchestration do? We'll come back to it. But before that, let me go to one slide, like this guy. Basically, what is this guy is doing? You often seen is this guy in a movie or some orchestra. He's doing nothing except guiding everybody to play which sound, which equipment, with like maybe he's guiding a guy. Okay, let's start piano, let's stop guitar and everything. This guy is controlling all of the people who are sitting in the orchestra. So yes, that's great, Horabas. Thank you. He's orchestrating. He is guiding everybody without saying a single word, with their action, with their gestures, with their maybe face expression, maybe body language, and they are communicating with like hundreds of people. It's not humanly possible that to communicate 100 people at one time, but this guy is doing the great job in a very efficient manner. So this guy is like a Kubernetes in the IT world. So let's come to the orchestration software. Uh, Container orchestration, there are many softwares, but definitely the Kubernetes is the worldwide king, you can say. Like 80-90% companies or resources are run by the Kubernetes. There are some features, there are some, you can say, USP, unique selling point. We'll discuss that. But what basically container orchestration does is important thing. There are plenty of lines written over here, but let me tell you in one single line. Orchestration means the software which orchestrate, or you can say, or in the easy word, to manage whole life cycle, starting from building container to managing expansion, scaling, troubleshooting, provisioning, availability, everything. The life cycle means the complete duration of existing of these container. So maybe there are one container, maybe there are thousands. Maybe the word is different. We don't call them containers in Kubernetes word, but for right now, you can say like containers. So to controlling whole life cycle of you can say containers or the pod is specifically the word is, it's being done by the container orchestration system, and Kubernetes is the you can say king of it. Actually, this is one of the open source software which was initially developed by Google, but later on it was delivered to cloud native computing, that is worldwide organization, and he is managing all that stuff, maybe expansion, their certification, their deployment, all that strategy of Kubernetes. So Kubernetes is an open source container management system for automating deployment, operations, scaling of containerized application, and creating clusters of container. I just read few lines. about Kubernetes that will help you to understand. Let me read it again. Kubernetes is an open source container management system. You just start focusing on each word. Container or management system, a system which manage like system, like we had learning management system, we have attendance management system, a system which is used to for controlling attendance of your whole employees. So it's a container management system, a system that manage all the containers for what purpose? For automating. It should be like automatic, you don't need the manual processes. Automating deployment to building and do operations, scaling of containerization. Like we have 100, we need to expand, so we need scaling. So it also does the scaling thing, and also creating clusters of container. Definitely, like I just give you example of Google, like they have 2 billion containers. So it's not possible that all these containers will be running on the same location. They are divided into different geographical location, different logical locations. So they just you can say they have a multiple clusters, they have multiple sectors, they are available. So controlling all that life cycle, maybe deployment, maybe scaling, maybe redundancy management, everything is being done by the Kubernetes. There are other softwares like Docker Swarm and all others, but Kubernetes is the one which is widely used. So it's a production grade container orchestration system, you can say. But that's the one question which often people ask, like how do we pronounce it? It's a little Greek word and difficult to pronounce sometimes. Some people say Kubernetes, some say Kubernetes. And so you can just call it K8s. The Kubernetes, in short, K8s means starting with K and end with S, and there are 8 letters between. So people normally, the techie world, people normally call it K8s. So you can say whatever you like. We discuss what K8 is. So I was discussing like Kubernetes is one of the most widely adopted and widely accepted. The reason are very much evident in that slide. Like in the last year, there's a high increase, and also the availability is very high, demand is very high, experts are very limited, and because of lack of training and networking needs are some more. These are some points which I just jot down. But a basic thing which comes every time when we search Kubernetes, maybe you can go to the Google Trend and find the word Kubernetes versus anything. So you will get to know the how much people are moving toward it. There are some other softwares, but the Kubernetes is being managed by CNCF. That is one of the reason, and it's an open source. That is second reason, and the third thing is that every major cloud provider is supporting that. Maybe you are running your resources on Huawei cloud, maybe on some other cloud, ABC, maybe you are running your resources on your private data center. Kubernetes can run everywhere. It's like if I give you a common life example. I have ABC mobile, I have Huawei mobile, I have Samsung mobile, but Android works everywhere. Maybe there little change in Huawei mobile, there's some little change in some other mobile, but that's thing which Kubernetes is available for every platform. Now, what is the importance of that? Or you can say, why do we need cloud native application? That is very important. There are many advantages. The first thing which is written over here is the one of the best thing. For example, faster release space. For example, I am working in a software company and developing a software, and that software is very much efficient, but it release date is in 2020 2028. So people will not wait. Maybe there are thousands of softwares that will come before that, but my software, the other company, they release software in next month, but it is full of bugs. So it should be very optimized. It should not be very fast, it should not be very slow, it should be optimized. So release cycle should be fast, because the changes are being made very fastly, but with some pace of accuracy. So Kubernetes, it's helping you to make release faster, because when you deploy your infrastructure, your software, your application on any cloud, it does not remain always safe. Maybe sometime the high number of users are there, sometimes the load are very minimum, sometimes people start using aggressively, sometimes they don't use much, sometimes traffic from certain location are there. Sometimes there is no traffic from any location. So these are all things. Sometimes there is an outage in certain areas. So all that stuff needs to be managed, and all that. If let me add some sentence so that cover the question as well. Kubernetes, as I mentioned, the Kubernetes is covering every aspect of your deployment. For example, I have one software I deploy over the cloud. I have different services. Like this software must have a networking part, some storage part, some computing part, some you can say computational part. So everything is being running on different resources of Kubernetes, and Kubernetes is managing all that resources. Different microservices are being, and Kubernetes is engaging with everybody, and they are expediting their operation very fastly. So that is some important things to discuss. But before going for further into the Kubernetes, let's discuss some architecture in a very quick manner, and then we'll see little benefits again, and then we'll focus on the lab part and different resources. But before the lab part, I'll try to explain few of the resources. Kubernetes has, you can say, hundreds of resources. To be specific, more than 200 resources, but we'll be considering the more famous ones, and then we'll deploy some application, and then we'll try to get some output from the Huawei cloud as well. So I was discussing that Kubernetes works in a cluster. Cluster is nothing but a combination of common type of equipment. For example, we say this is a cluster of server. So there are hundreds of servers are working. This is a cluster of storage devices. So bunch of storage devices are over there. So the Kubernetes cluster is something which you can build on your physical or on the VMs or any public cloud, but they are the same, different nodes. All nodes are running Kubernetes. So there are two types of node basically. One is master node. Most of them are the worker node. Normally, it's a good practice to have at least 3 master nodes, and then you have multiple worker nodes. Fine. So master node is the one which is more like a controlling plane, which doesn't do any operation except controlling all that worker nodes. And worker nodes are the computers or the machines or the VMs where your application, your containerized application are hosted and they are all working. If you see this diagram, you will see there's a one master node and one worker node. Master node has different, you can say, blocks like API servers, scheduler. We'll discuss what these are. And then we have a worker node, which has 2 or 3 parts like proxy, kubelet, and CRI, container runtime interface. And then we have different loads containers. So this is, you can say, one block diagram of number of worker nodes can be as much as possible, but maximum tested with the Kubernetes is 5,000. Definitely, there's no company in the world which will make that much higher number of nodes, because it's not easy to manage, and it's not a efficient resource of utilization. So they make multiple clusters according to their use, their use case. For example, if I say our whole resources of Huawei is running on Kubernetes cluster, so it's not possible that they will make one giant cluster. They will make one cluster for Huawei cloud, one cluster for Huawei, you can say, community cloud, one cluster for enterprise solutions, one for the corporate solutions. So maybe they divide into multiples. So, but if you, for your answer question, you have 5,000 is it's the maximum number tested by the Kubernetes. So this is one more advantage of Kubernetes. They can scale up to higher number like 5,000. Okay. Which is better, master node and worker node? There is nothing comparison between. Everything is important. What do you say? You are the best, or your manager? Both has their job. The manager is, or team lead is the one who control all the team member. They're working their KPI management and everything. The master node is the one which gives controlling to all the worker nodes, and worker nodes are there to make pods and resources and everything. So if master fails, what happens? That's a very good question. So if you remember, I said it's always a good practice to at least have a 3 master nodes. That's in very rare case that one master fail and then second fail and then third fail. So every time you have a backup. If one fails, you will make one more. So the count becomes 3. But in normal small organization or in the testing phase, we have one master and one worker node and we use it. But in the production network, we have always the multiple level of redundancy. Even like, for example, in our normal lab system, we have one laptop, but in our company, we don't have one laptop, we have multiple servers. If one server fails, another one comes in. Okay. And so if I move a little further and describe all these parts again, like master node, what are the parts of master node and what are the parts in the, you can say, worker node. First of all, start with a master node. As the name says, it's a master, or you can say controller node for controlling all that application, all that information. Okay, so I think just to hold a question, you be right. I'll answer after a few slides. I'll answer everything. Yes, we can use master as worker as well, but definitely we don't use because every node has a specific work to do. Your team lead can do your job, but normally he doesn't do that. Okay, he has another things to do. Okay, so let's come to master node first, and then we'll go to the worker nodes. Okay, so master node is the one which control all that activity. For example, starting from the information taken from yourself. For example, you being the Kubernetes administrator or the DevOps guy, you give a command to master node, and then master node will be responsible for getting it executed from the worker nodes. It's like the same example which I've multiple time I've given you example about your team. Like you have 5 people in your team, and there's one team lead who is receiving tasks from your manager or from the peer department, and then he is responsible for distributing according to the resources capability and resources availability. So the master node is the same. He get receives. Let me draw for you. Okay, so kubectl is a tool which is used for giving information or giving command to the master node. So let's say this is kubectl, and then this interact with API server, which is a one part of master node, which is responsible for covering different jobs. For example, interacting within the master node, interacting with the worker nodes, and interacting with the kubectl, or you can say human. Okay, let's do one thing very quick. Let's focus this part, and then we will start asking question, because if you focus over here, maybe most of your question will be asked will be gotten from my discussion. If still, I'll promise I'll answer one by one after this topic or this session. Let's don't worry about that. So the master node has different parts like schedule, controller, etcd, API server. That's great. So API server is more like you can say a main controller part, and a life of, you can say, master node, which interact with different part. Maybe he get information from kubectl or from the GUI, and then execute it on worker nodes and the master nodes. Fine. So let's be patient. We haven't discussed kubelet yet. We haven't discussed Kubernetes pod. You will get to know everything. Don't worry about it. We have extensive slides. We have different topic, and I have will be writing an article on it. Don't worry about it. You will get everything. Don't worry. And if you have questions, still, if you, in your mind, you may write on. You can say on the forum, on the post. I'll try to answer everyone. Don't worry about that. So let's focus on this slide first. So the API server is the one which is, you can say, uh, a main part of a master node, and it is responsible to interacting and getting the task done with different participants, like worker nodes, with the, you can say, from the exterior world, from the organization, and everything. So when information comes to API server, and it has to communicate with all that stuff, then what does it do? It asks a scheduler to see if resources are available on our worker nodes, so I can assign somebody this task. For example, I receive one request from kubectl that please provide a resource, one pod. I don't know what is pod. Let's say right now we don't know what is pod. let's say we got a request from kubectl that I need one container in a easy word. So API server will receive this, and then he asks scheduler, so do you have resources available in any of your worker node? Let me know so I can assign. Then scheduler say, okay, let me see. And then the controller manager, this the second part, third part basically, and he's basically continuously looking the state of every worker node, every resource, what is the are they are having their desired rate and everything. If the state is available, then API server interact with etcd. Etcd is nothing but a database which stores every information about the resources. For example, we have not discussed the resources, but just for your common life knowledge, like resources means volume resource or networking resource or the pod or the container. So every manifest is available in the etcd. It's a database. So the API server will go to the database and give me the you can say template of pod. Let me give this. Let me give this to one of my worker node so they can develop. So the what should the flow becomes? kubectl gives the request to the API server that create one uh, container with ABC requirements. So he go to the scheduler and controller and get the manifest from the etcd, and then etcd give this template, and then API server send this to worker node, and worker node deploy that resource in worker node 1. But how it will deploy, that we will cover in the second part. What worker node does, that is important thing. So there are four major parts: API server, and then scheduler, which is responsible for monitoring resource uses and everything; controller, which always takes the what is the current state; and etcd is more like a database, or you can say it is store key value pair of all that API objects. Now comes to the second part, which is for the worker node. Okay, so worker node has two basic parts and one another part. The first part is kube proxy, and the second part is kubelet, and then we have a CRI, where in this slide it is written as like a Docker, but Docker can be replaced with any other software. But kubelet is a must. Kubelet is the same like a manager of worker node. All the information received from API server will be interacted with the kubelet. Every worker node must have one kubelet. Kubelet is the main, you can say, head office of that worker node. It controls all the information in and out. If any information which is required from outside world, then kubelet asks kubeproxy to communicate. For example, I have received this request from kubectl and then API server that I need one container which is running Nginx, that is a web server. Definitely kubelet doesn't have the information about Nginx, so he asked kubeproxy to get this information from Docker Hub or from any third-party media, and then kubeproxy will do their job. Kubeproxy is more like a networking part. It's like a router, or you can say gateway to outside world, and then he will try to get that information for you. And then kubelet will ask Docker to make the image, make the container from this image and run different containers. For right now, one container is equal to one pod for you, but we will discuss what's the difference between pod and the container. A very quick question: are Kubernetes and Docker related? Definitely, they are related. Docker or any container management software is there to create containers, and Kubernetes are there to manage these containers. So we used to we used to use Docker initially in Kubernetes, but now we are using CRI, any software which can make container runtime. Okay, so that is the flow. Let me explain this in a another way. Uh, so we'll be having a revision and also in a graphical form. For example, this diagram will show you another perspective. For example, I got one information from my Kubernetes administrator that uh, I need two deployments, one of, let's say, Nginx, another of MongoDB, let's say. So it comes to API server. What API server will do, he will ask controller manager to see what is the current status of resources and object. Everything is a resource. For example, right now we don't know much of the resources. We know container is one resource, and we know storage is one resource. We know networking is one resource. So the controller manager, the name shows, it says resource object management. And then the scheduler is like more like you can say timekeeper, which has to create what is the time to make these, all that scheduling. It's more like a scheduling. And etcd store the states, what is the current state. Okay, that's the important thing. All that comes, all that things which you are asking will come later. Services, cluster, don't worry about anything. Try to focus which I am trying to deliver right now. You will get everything. Don't worry about it. If we'll not cover in this part, we'll be having another part for the community. Don't need to worry about anything. So yes, so these three parts will help create our resources. And then kubelet is the one which is to create container. But as kubelet got the information, kubelet said, I don't have that image. So he asked the proxy, which I show you in the last figure. So in a very quick manner, yes, etcd is like more like a database. In a short, I said it stores values in a key value pair in a form, and like every resource, state of every resource is saved in etcd. It is, if you see in a Kubernetes cluster, etcd is a database. You can easily get. Okay, so again, the flow, what the complete flow like this. If I get information in a YAML file or in the command form, I got from the administrator, which will come to the API server. It up in this diagram, it is very easy because it's a block diagram and the one liner is written over here just for your understanding. Server which handles change request. Like I got, I'm running 5 deployments and another request comes in, like I need one pod or one container. So it receives the change request. In etcd, it store the configuration. I know this is database. The controller watch the etcd change, like we have 2 data, 5 deployment was running. I need one more pod. So the controller watches the etcd for the changes, and all the changes which are difference will be go to the scheduler, and the scheduler will ask the worker node to make this thing happen. For example, right now we have 5 deployment and I need one more pod. So the addition of pod will be coming from the master node and to the worker node. Node or the worker node are the same thing. He will ask to the kubelet, and kubelet will see if the image is available. That's good. He will ask CRI to make that container and then that container. Otherwise, he will ask kube proxy to guide this image from the third party, and that whole life cycle will be like this. kubectl, or in the short form, Kubernetes control or kubectl. It's a language, or it's a you can say command line to give information to the Kubernetes world. There are 2 types of information you can give it in a text form in a CLI mode. One is with the use of kubectl, or one is in a form of a YAML file. Maybe you ask him like, please create 2 containers in one line, or maybe you can ask like to create a batch file which has all that information. One is descriptive form, one is imperative code. So we'll see that thing as well. Don't worry. But now the important thing is workloads. What workload or what sort of a resources can be run or managed by the Kubernetes? That is very important question. That question I was thinking somebody will ask. But for your surprise, there are only few resources which is mentioned in this slide, but there are more than 200 resources that Kubernetes can run or can manage. There are some resources, like for example, volumes. Volume is a storage location. I know that thing for sure, but volume can be of different types. Storage can be simple storage in your hard disk. It could be NFS. It could be anything. So it could be on AWS. It could be on Huawei Cloud. Kubernetes can manage most of them. Some will be owned by the administrator, some will be owned by third-party providers. Okay, So these are literally very few resources which we normally uh, see. So we'll start with a very basic one, or you can say the very atomic unit. If I say what is the atomic unit of length, you will say, yeah, what is the basic unit of length or SI unit of length? You will say meter. If the length increases, you will count in kilometer, then things goes on. But the meter is the atomic unit. In the Kubernetes world, in the containerization world, the basic unit is pod. For your understanding, I asked you in the initial phase that one pod is equal to one container. But now we will deep dive more and we'll discuss how they are different and how they are interrelated. So if I jot down different resources in one block diagram, so it will be more like this. There's a one big namespace. Namespace is a logical isolation. I have a cluster of 200 nodes, but definitely all these 200 nodes are not supposed to talk to each other. So I'll divide into a separate part. Like if I give you a common life example, in our office, we have like 500 people sitting in our building, but definitely everybody has not supposed to talk to each other and not discuss everything. Maybe finance department has different things to deal. Technical department doesn't share any information with the sales department. Corporate department doesn't discuss or share knowledge with HR department. HR has different set of rules. So we divided them into the cubicles, or you can see the floors, or maybe in the different parts. But that all belongs to one office, ABC office, and they all are the member of that office. But they are divided into departments, so they can segregate their work, they can use their resources efficiently, and they execute their job. So here in the cluster, we will make different namespaces. For example, I can have three namespaces in my network in my cluster. One is production, one is development, and one is testing. So testing resources will not be bothering production network. Production networks output will not affect on development. And or maybe you can divide into a customer. Like I have one infrastructure, my customer ABC, other customer is XYZ, and other customer is MNO. So MNO should not communicate with XYZ, XYZ data should not communicate with ABC. So we will make division, and then this division is called namespace. If you are from the networking world, you know the concept of VLAN. VLAN is a virtual segregation of a network. Fine. So namespace is more like a resource, more like a logical one, which divide different resources in a one group. Then we have one resource, which is pod. Pod is the most common resource. You can say it's an atomic unit, the first resource which we use in any Kubernetes world. It's, or you can say the container. One pod is equal to one container, but pod can have multiple containers as well. Don't worry. But normally in the normal run, we say like this. Yeah, if you see this diagram, a container is, you know what is container, but the pod is the atomic unit of Kubernetes, which has one container in it. There are some time when we have multiple containers, but normally, like 90-95%, we have one pod is equal to one container. But there are some certain conditions when we need two processes to run together. For example, one is a web server, one is the logical, you can say, storage of location of maybe some logs, vagara, logs and something. So we need two containers to run in a single pod. But we normally don't prefer, because if we put multiple containers in one pod, that will going to harm our microservices ideology. Microservices ideology is something which is we are dividing the work into a smaller part. So if we are combining two or three smaller tasks together, then definitely we will be not focusing on the microservices approaches. So in the easy way, or you can say the one pod is equal to one container. Whenever I say pod, you can easily remember that it's we are talking about the container. If I say about container, then you can easily understand we are talking about the pod in the Kubernetes world. And node is a machine where all that containers and the pods are running. So that's not the not a big deal to worry about. Now let's come to some other resources. So we discussed about the pod. it's a smaller deployable unit. You can say smaller deployable resource. For example, I need to deploy a website on Kubernetes cluster. So what I will do, I will deploy that website in a pod, and then that pod will be running my Nginx server or any web server. And then whenever I access that pod, I will get my website. But definitely pod is one computing resource. I need some other resources as well. I need a networking of to reach to that pod. I might need some storage and other stuff. So all that resources are different resources. You can combine together to make your effort. For example, if somebody comes in, I need to deploy my database server. So don't need, they just need a pod or deployment. Maybe they don't need an external networking because they don't want this database to interact with the external world. Maybe they need a service which is only to the accessible to the local world. So there are two different ways to make a pod. Maybe you can write a kubectl command as I discussed in the previous slide, or maybe you can write a bunch of lines which is in form of a YAML language, and that is called declarative method, where you are defining that the name should be Nginx, image should be Nginx, port number 8080 should be used, and the name of pod should be simple.web app. So you can have different things. Okay, and the one thing which is very important concept in cloud native, especially in containerization and especially in Kubernetes, it's ephemeral. The nature is ephemeral. That the pods or any resource, they are bound to die. They die after some time, maybe after 2 years, 3 years, 100 years, or maybe after 2 seconds. So they can keeps on creating. We don't need to run again and again. We don't need uh, to think like normal traditional servers where you just brought a server and it will last for like 100 months or something. So we design network in that way. If any pod comes in or comes out, our services will not be affected. What does that mean? For example, if I need to deploy a website, so I will not be using a pod alone. Maybe I'll deploy my website into multiple pods. So if one pod die, I don't worry. If two pods die, I don't need to worry. If three pods die, even still I don't need to worry because I have multiples available. And if one pods die, and traffic shifts to second one, and then the first pod will become restarted and everything. And if you need to store data, then you don't need to store it on the pod, because pod, I know pod is keeps on dying and keeps uh, establishing again. So we store data in some volume or some storage. It is same like you store your confidential data in not on your laptop, maybe in your pocket device or in your USB or in your maybe in your online storage. So every time if I go to the other laptop, my data should be reserved. If anything bad's happened to my laptop also, so you will be having your data saved. So that is all about pod. So how to interact with pod? Because pod is running on their node. Maybe if I'm sitting on that node, I can access. But what uh, if a people or my party, my colleague is sitting on the cluster, and he's also want to access this pod. So what he will do? He can access or not? This is the question to you from my side. Let me see the chat first. So we are sitting in a cluster, and I deploy a pod, and I'm working on that pod. But one of my colleague also wants to access that pod. How can he, is it possible he can access? Okay, I got few answer. No, he cannot. Okay, it depends upon the network. If I say they are on the same cluster, definitely they can access, but which need some services, which need some access. For example, if I have one file in my laptop, I need to share that file. Just a minute.
Take your time, drink some water, don't worry. Okay.
Sorry, apologies. Okay, so let's say I have one file available in my laptop and we are sitting on the same office, but we cannot share data until I save this file and share with my colleague. I'll go and allow a sharing option, and then I can share. So I need to create some services. This type of service can be changed. It could be internal, it could be external. Okay. So so back again. So that is called services. This is the second topic which we need to consider. Services is the way of accessing. Very right. So how do you access these services? Is it within the cluster, outside the cluster, within the node, outside the node, everything? There are three major types. The first one is cluster IP, which means that all the resources can be accessible within the cluster. Maybe I have one node in my cluster, or maybe I can have 1,000 nodes in my cluster. That if I create cluster IP, then it's mean I can access that resource from any of the node, but within that node. But if I want that this resource is accessible to other node as well, so I'll create node port. And if I want this resource is accessible to the external world, then I'll be using load balancer or some other, but normally load balancers are being used. So these are three services. The diagram are very much visible. That these services also is very important in to provide the path, and also it helps us in distributing that task. If we see the first diagram in the left side, let me draw. Let's say I create a one logical resource that is called services, and which interact with three pods. And if I comes here, so the services will divide my traffic to this pod, sometime to this pod, sometime to this pod. So not only this is providing me the path, which it's also providing me the redundancy, it's also providing me to the balancing. Okay. And this is the cluster IP, only accessible within the cluster. But if I want to access this services or this pod from the outside world, for example, these pods are hosted in my data center in Dubai, but I am sitting in Pakistan. So I need a load balancer, which is like more like a, in an easy word, if I say, it's a router with a public IP. So I can access my load balancer from any part.
Kashif, please know that I cannot hear you. Can someone please confirm in the chat if you can hear if you can hear Bashir or not? Okay, so it's not just for me. Okay, Bashir, please know that we cannot hear you, so maybe you should try to maybe exit the meeting and join it again. Yes, I informed Bashir that we cannot hear, and maybe he will rejoin the meeting. So please wait for 1 minute before he's able to join the meeting again. Okay.
Please unmute. Okay, that's
Okay.
great.
Hello. I can hear you now. We weren't able to hear you for about 2 minutes, I think.
Okay. 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 Let me show screen first. Okay, so where were we? Okay, where we lost? Can you just repeat where were the? Are we clear with the cluster IP or load balancer?
Okay.
Load balancer. That's
Load
great.
balancer.
That's great. Okay, that's great. Okay, that's great. Last one. Okay, that's great. Thank you, Abdurrahman. So load balancer has the his job. Everybody has a certain job to follow. The load balancer is a one which is communicating with the outside world, and then it's sending information to the services. Services will divide the traffic to the different pods. But definitely load balancer will not do any job except until he has one public IP. So he can reachable to the world, and world can reach to load balancer as well. So services are the logical resources, but very important to have. Now we'll see some more resources. Okay, before going to the resources, let's discuss some concept. Like this white box is one pod which has multiple containers. I said the ideally should be one, but sometimes we need one or more containers. So let's say we have two containers. One is Nginx container, one is a logger, which is supposed to store logs. But the IP is available on pod, not on the container. So it's mean both container will be having the same IP, and there are multiple of pods available in the node. So node has one IP, pod has one IP. So if I want to access this container, I need services to create. Okay, now comes the deployment. Now we have discussed like the pod and everything, but I also mentioned one thing in the start that we don't deploy anything on the pod. We'll make it redundant. We make it multiple in accounts. So we make a deployment is a upper layer. You can say it consists of different resources, and in that resources you have multiple pods. Even if you need to deploy your application in one pod, you will make a deployment is you can say it's a whole project. In project maybe there are one person, maybe in a project you have 1,000 persons, and everybody has a different jobs. So the deployment will manage everything, the pods, the resources, the volume, and other services and everything. Then you will create services to the deployment, not to the pod, because we know the pod are the one with the nature of recreating. So if I create one service with the pod and pod is die, so what we will do? So we will make, or maybe we need expansion. We previously we had one pod, now we need two or three or four. So that would be difficult to shift traffic from one pod to multiple pods. So we will create deployment even if the number of participant, number of pod are or only one. But now normally we don't create any single pod or a deployment with single pod. We create with a different pod, because containers or the pods are very small unit. You can run multiple containers. That is not the issue. So you can say deployment is the upper layer. It's an umbrella which consists of different part. You can run multiple pods in it. You can create a service with a deployment, and uh, you can create different volumes attached with the deployments. So all the pods which is in the deployment will be accessing these volume. Volume is a storage, basically is a location. So deployment and other resources which we can discuss is jobs and a cron job. Before jobs and cron job, we'll discuss one thing. Like in our Windows or in our Linux system, we have a software which is called a scheduler. Maybe I created a batch file in a Linux, and I said this batch file should run at 3 a.m. in the night, for example. In WhatsApp, we have a backup schedule at 2 a.m. in the night. So I said, this is my file and it has to run on every Tuesday at 3 p.m. in the afternoon. So we create a job or a cron job. Cron job is the job with some time bound limit. That I need this resource when, for example, a certain action is performed, then this job has to perform. And job is basically a part with certain tasks. Like I need all the job is to create uh, what job will do that he will interact with every node of the cluster and get his IP and every information. So that is a certain task which needs to perform repeatedly or maybe at certain time. So we create jobs and cron jobs. You can say it's a small task which is being created. Jobs and cron jobs create at any layer. For example, maybe during execution, before execution, like every resource in Kubernetes can be created via the command line. Like I said, kubectl create an ABC, or maybe I can write a YAML and then I'll uh, I'll create that resources. Maybe I can write a big YAML which consists everything, starting with the deployment, then resources or services, then cron jobs and jobs, and then something for the volumes. So we'll write one big giant YAML and then run that, and boom, everything is created. The whole infrastructure is ready. That is the beauty of Kubernetes. But for understanding, we are creating, or we are discussing one by one. And then definitely you can use these resources as per your need. Definitely, maybe some organization, they are only using deployment and the volumes. They don't need anything. But some companies, maybe they are using volumes and jobs and uh, all other thing. So every time all that resources are being made on the infrastructure, that infrastructure needs to manage by the operator or by the company. So that remain always been a hassle. So we use the support from our cloud providers like Huawei Cloud and AWS and Google. So they have to maintain all that infrastructure problem, resources problem, and then we'll do the operations and we will do the task and get most of it. So we have one service available in Huawei Cloud, that is CCI, Cloud Container Instance. That is basically a serverless engine. So what this service does is give you a platform, and you said I need this thing. For example, I can go and I ask I need 2 deployments. So they will manage everything. They will give you the output of 2 deployment. Maybe you can ask him create 2 deployment, one for Nginx, one for uh, Apache, and all that stuff which we are discussing will be managed by the Huawei Cloud. It's the same example if I code it with a normal life. In normal life, what we do in cloud providers, we ask him that provide 2 VMs, 2 ECS machines for Huawei Cloud. Name can be different to different vendors. But if we need 2 computing resources, we just go to the cloud provider and then said, okay, give me 100 resources. Okay, so 100 resources. So all that problem, availability of server, availability of networking, availability of security, everything has to maintain by the cloud service provider. We need to have the platform available and we'll work according to our need. Maybe we install any software on it. Maybe we use as our deployment phase. We need for some testing purposes. So this is a good thing. So CCI is the same thing, which is a serverless container engine. It is used to run different containers, different Kubernetes resources without worrying about how to manage it, how to deploy it, how to operate it. We just got the output and we'll use it. So CCI is one of the good resources. I'll be sharing one article over it on this by tomorrow something. So you will get to know more about CCI. There are so many advantages. It's a one-stop container lifecycle. Like we say, Kubernetes is the one which is manage everything, but the physical hardware, the infrastructure has to maintain by CCI, and we will be using Kubernetes and everything. So manage all that stuff. Now we will be moving toward the lab part. But before going to the lab part, I'll be trying answering some questions in a quick manner because most of the questions are being already answered, and some questions are not very much related. Like, what is the difference between pod and deployment? Pod is like, we have discussed this thing, great. Can you explain different Kubernetes pods? Like, pods is a computing resource, I said, you can use in a different manner. For example, one is a main container. There are different pods type. Like, one um, one pod is used for the doing certain task. One type of pod is used to complement that task. For example, I give you example of that logging. One container for the for the web server. Other one is for the logging part. It is just to save the logs and everything, which is commonly called as a sidecar. Okay, at what level CG are created? Already answered. What is the difference between Kubernetes and the container? Container is a computing resource. Kubernetes is the one which is managing all that containers. What is the limitation using default namespace? It's same like that. If your whole office is sitting on a one floor, so you can tell me what are the limitations. Everybody is mess up with each other. You cannot divide like who is management layer, who is marketing guy, how to communicate, and there's a so much loud. Common issues with Kubernetes. The one thing which is Kubernetes, the issue or the challenge is the somehow complexity or lack of resources, because the resources in terms of human resources. What communication path between API servers to node, pod, and services? We have discussed this thing in a detailed manner, how to set resource requests and limits. Okay, so one thing, how to set resource. This is an advanced topic, but just to give you an answer in a quick way, every resource can be controlled. Like I said, pod is a small computing resources, so we will not be trying to think like, for example, my pod is a small resource and I don't want to put heavy load on it. So we will put some limitation. For example, this pod should not go to the 200 milli CPU. This is a, for example, unit of CPU, or maybe XYZ information. So we can limit and request it. If this much request comes, then serve it. Otherwise, go to another pod or maybe add some more. This is called scaling up. Which programming language is used in kubectl? Kubectl is basically a set of instruction in which you write like kubectl create deployment. The kubectl is a word, and then create is an action, and then object. In like in English, we use subject verb object. Is more like this. Subject is the kubectl, and action is a create, delete, and something, and then object is what you want and how do you want. But the best thing is to use YAML. So let me go to console. Let me open console. Okay, that's a good question, Fahad. Hi, Bashir. In case of disaster, could you please explain the backup restoration? Okay, that is the reactive approach. The proactive approach is to make system very efficient. For example, start with let's say you'll deploy in a redundant method. For example, every resource should be redundant in sort of a in form of a resources, in form of geographical location, in form of a availability. And definitely, as I mentioned, normally we used three masters and multiple workers. Definitely, we will be not saying like you will create one worker node and deploy all the resources on that worker node. What if this worker node fails due to any reason? So we need multiple. So redundancy has to maintain at every layer. It's not about only the resources. Okay, please give some example of security measures for Kubernetes. Okay, I'll give you two or three. Then you will thank you, Fiza. Uh, will you understand? For example, I have multiple worker nodes. Okay, and they are available on internet. So when you add that worker node, there is a security encryption. There is a security mechanism. Only with the particular you share the key, and then only the specific worker node can access. And all these worker nodes are on the private IP, so it is accessible to you wherever you want this service, the resource which you need. By default, everything is under the private hood. If you need some resource to be publicly available, then you will create a load balancing or ingress server or something, and then you give the availability of internet to that resource only. Okay, so good question. I'll explain more. So let's come to the our lab part. Before going to lab part, let me show you some things and then go. But there are multiple resources available. You know, we have discussed a lot of these things. And these are multiple steps we are following. First, we'll create namespace, then subnet, then deployment. How do we deploy? By using YAML. And then we will use CCI to acknowledge. Otherwise, we need to create cluster. We need to manage clusters with different nodes. But thanks to Huawei Cloud CCI, that will do all our job. Okay, so this is, you can say, our steps. I'll just jot down for you. And these are some steps because this presentation is available for you for future reference as well. But definitely all that stuff will be showing to you. So let's go to the our console. Let's say this is our console. Let's go to the resources. You can see this is computing resource, storage resource, networking, all that, but we'll be considering of the containers. Right now we are using CCI, which is Cloud Container Instance, or in short CCI. CCI is basically a serverless engine which provide you about the availability of resources. All are being managed by Huawei, so you don't need to worry about anything. The first step is to create namespace because we need a isolation from the main part. Okay, so right now, okay, so the step is very simple. Create a namespace. I can give a name, or VPC. Okay, let's say I use the existing VPC. There's multiple VPCs I have available. So, and then I'll define which subnet. Let's say I use subnet 1, which is 10.0.0.0/24. And then I create. So namespace is just a logical one. Now I can create workloads. How I will create? Let's say this is this stepwise. I create a namespace with the subnet. Right now I have, what is this? Okay, so these are the steps which we need to follow. Okay, let's say now go to the namespace list. Now you can see multiple namespaces available. Right now I have only one. You can create multiple namespaces. Okay, so let's go to the workloads. Now we can deploy different workloads. Okay, so like we have deployment, we can have job, we can have cron jobs, we can have pods, but we cannot create pod directly. We need to create a deployment. Okay, as soon as we create deployment, you will see the pods are being created over here. So first of all, there are two options to create deployment. Either you use an image, if you have image available, or you can write a YAML. YAML is a form of language that will provide every information that what do you need, it's an extensive thing. Maybe I'll share something on a forum how to read that YAML and everything, or maybe we'll discuss in some other session that how to write YAML and how to make it efficient. Okay, so what is this line? Anyways, so we have two options. So I'll be using create from YAML. Okay, this is one simple configuration available. We can add this and we can even download it. Now you can see the important thing. First of all, kind means what is the type of resources. We are using deployment. The important thing, replicas, how many pods are there? Replica is 1. It's mean how many pods? I said you can have it like 8, 2, whatever. Let's say I'll put 2. And then important thing is specification. The image name is Nginx. I'm using Nginx container image. It's mean I'm deploying a web server for you, and then this web server is used to host a website, and then will try to access this website from the external world as well. And then we put some limit, like should be 1 CPU, memory should be 2 GB and something. This is the limit, this is the request. Okay, and then we create. Okay, it takes little time. Meanwhile, it is deploying. What we can do, we can create a lot networking part as well. It takes like 20-30 seconds to make it available, and then we go to the pods, and you can see pods also starting deployment well. Do you remember I put replica 2, so you can see 2 pods are there. It's mean if one pod is die, still my services is okay to have. As soon this pod die, services will be running from here, and then this pod starts recreating itself by the use of Kubernetes. This is the beauty of Kubernetes. As soon as this die, it will again restart, or it will maybe, and if the load increases, maybe 2 or 3 pods more will be created. Okay, so these are the 2 pods which is having a image of Nginx. But the important thing is, let's go to deployment first. Now you can see pod is normal 2 by 2. It's been 2 was suggested and 2 is okay. Let's go into it, and you can see all the information. The pod list. The pod number 1 is running. The IP is there. Request is there. The cost is there, and each pod is having this availability. I can see event, all that stuff which we normally use with the CLI. Now we can see in a one window using Huawei CCI. So you can see replica created, all that logs which normally we use by the command. Okay. Okay. Now we can add scaling. We can add 2 more instances and something like this. And the good thing is that I have all the information about this pod available in one window. I can see log. I can delete the one pod. Let's say uh, this is one pod 10.0.0.86. Let's say we delete this pod. Maybe it got some error or something. So as soon as this is ending, the another one is creating. That is the beauty. And if I go to the pod, you will see now 3. You will see 2 pods available, because we defined 2 should be available at every time, regardless of the fact. So 2 by 2. Still, 1 was gone, and now the IP is changed. Previously, it was 86. So maybe this pod has some issue, or anything comes problem with this pod. So this can easily. I can access this pod using some information. Maybe I can access the container in it. Even I can go to this container by using CLI. Let's say I can put any command. Let's say alias, because every container is a small computing resources. I can put something on it and will have a good idea about it. But right now, what happened? This is a deployment which having 2 pods, but they are not accessible to the outside world because they don't have any services. So let's create some service for it, and then we'll see something for this. So let's go to networking and load balance. Okay, right now we don't have any load balancer. It's been no connectivity with the outside. So let's buy Elastic Cloud. Okay, we don't need the dedicated one. The shared one is fine. B, remember the VPC name. We have multiple VPCs. I use the C1. B, that's fine. Subnet 1 was used. That's fine. Okay, and the traffic of 5 MB is enough for me. Simple option. Elastic load balance is very easy option, not to worry about. Maybe I'll write the article. I'll snapshot every step one by one for you. Don't worry about it. Hit next, and now they will show you the region is Singapore. The name is this. Just make sure the VPC and subnet should be accurate. Otherwise, definitely my load balancer will not be able to communicate with my resources of Kubernetes. Let's put create for a while. It takes little time, and now you will see start running, but still it is not having public IP. Right now it's having only private IP. Let's wait for a while. Let's see, we have enabled public IP or not. Yes, we got this. Okay, this is the public IP which we are having. Let me, okay, this is the public IP. Let me copy this and open over here. Right now, this load balancer is not accessible. Nothing is available in this. What we will do, we will add a listener over here, because this load balancer should communicate with our CCI. Let's go to our CCI. And this is a dashboard, like we have one deployment, one is okay, 2 out of 2 pod is okay. Green means available, red means unavailable or abnormal, yellow means deleting or something. So we have some resources available over there. Now let's go to the services, because we need to communicate this resources with the outside world. Okay, by default, this is the cube services. Don't worry about it. This is by default service. Okay, now what we want, we have two types of service, cluster IP or the load balance. Okay, so we'll create load balancer because we need this resources to be communicate with the outside world as well. So first of all, what we will do, the name of namespace, we have only one, that's why we select this one. And then workload, we have one workload, that is CCI, we select this thing. And then which load balancer we use, we have only one, that's why it is selected by default. And which port you need to be accessed, because we are running Nginx, that is a web server, and we need port 80 to be allowed. Now, just to repeat again, the load balancer service is to use to communicate our local resources with the outside world. Though we define different parameter. Namespace, we have only one namespace, so by default it is selected. And then we select workload. This is important. Which workload you need to communicate? Right now we said our deployment should connect with my load balancer, so I can access load balancer, so I can reach to my deployment. And then service name, he created by themselves. And then it should be public network, because I want it to be reachable to the public. I can make it private as well, but I don't need it to make it private. The important thing is which port I need to use. I said I use TCP or UDP. I said I need a TCP port 80, and then container port is also port 80. Maybe if I have multiple containers, I can use different ports, and I create submit. Service is created. Let's wait for a while. Okay, service created. Now tell me, if I refresh this page, what should, oh, it's already refreshed. So I can see my Nginx page is reachable, but it's a default Nginx page. But I want this Nginx page to be changed, because I need to change this website. So I can say thank you to all of you to attend this webinar even during the holidays. So what I can do, I can go to the deployment. Let's say go to the pod and open one pod. We had two pods, I remember. One with IP of 87, I guess. Let me see. One is with the 87, other was with 235. We have two pods. Let's see, we'll go to one pod, like say this one, and go to their CLI. What if I change the index file so I can see this file? Let's say what I can do, find something, or actually I'm doing nothing. I'm just trying to change this text so we can see this text as well. What is this text? Welcome to Nginx. Let me copy this for you. Okay, I can do one thing. User and put it into user. I get share nginx index HTML index. Okay, let's try to refresh this now for multiple time because we have made a change on a pod level, not on a deployment level. Maybe you can open this link and try if it is updated, or maybe we can. Okay, so we can do one thing. We can copy this line and change this to be made on deployment level. So it will be accessible to all the pods. Let's say okay, let's refresh now. This is one pod. Let's say okay, so that's visible. So that was the location. I was copying a wrong location. So anyhow, so you can see I can change my website and deploy. So I don't need to worry about the infrastructure and anything. We just focus on the objective. The objective was to learn different resources and how to use that resources with the use of CCN, and CCI is very you can say customizable, very elaborative. You can have different options, like the dashboard is very much elaborative. You can see different KPIs and everything. I have number of resources, how many memories, any issues will be there, how many CPU uses are there. You can create job, you can do some deployment. So before handing over to Miss Alina, let's see a few questions if we have. Where do we? Okay, that is. Let me answer her, but in a quick and easy way to everybody else can understand. Otherwise, you can discuss me later on offline. The config map or the secrets are the location, or you can say small storage location where you store some information, which is like it's like a variable location. Or secret are like the password. Config map is something resource where you store the username and something, or secrets are the one which is used for some private data like passwords, your PIN number, your security tokens, and everything. And they are stored ideally on the pod level, but you can store it to some other location just for make it secure. Okay, and the other part is that everybody cannot see, because definitely your access to your CCI is not uh, available to anybody else except you share the password and everything. It's same like I have something confidential in my email, but that is not visible to you or anybody else until unless I have shared the password. Even we have MFA available. Even if my password is shared, nobody will be able to get into my email. So thank you for the question. Thank you for the appreciation, Ms. Big Bang. Takopedia, everyone. Maybe I don't remember the name. Babar, Fahad, thank you. Miss Hafiza, Babar Bashir, thank you. So open to have a question. Meanwhile, I'll go to the top. Or sometime, thank you, Kimi. People from Nigeria is there, from everywhere. That's great. How many containers run in a pod? I can run multiple containers, but definitely we don't do this unless it is very much required. Ideally, one container is equal to one pod. What is a Kubernetes stateful set? Okay, these are multiple resources we need. The state should be available. Without access, he cannot. Achha, this is something which you answer. Services are used to connect the pod very right. Or what is the security consider? We have discussed this thing. What is, can you explain the difference between Kubernetes pod and deployment? We have discussed, Saqib, that's great. Can we share config or data between two namespaces if there is a requirement? Yes, Mr. Zadi, we can do it. Or network on which node? Kubernetes network proxy or kubeproxy? Kubeproxy is run on Workadot, which is responsible for getting information from the outside world. And what is the role of scheduler? We have discussed. Do Kubernetes pods share resources? Ms. Afza, I did not get your question. Resources share, the pod is itself a resources, but definitely pod does not work alone. It's need different resources as well. And what is container resource monitoring? Thank you. Good question, half engineer. Every resource can be monitored with different KPI. For example, if you are using CCI, you can use dashboard option. This is the dashboard option. You can we can monitor different things. But there are some tools which will also use to monitor the resources. And if I go to the workload and click on deployment, then I can monitor my deployment. All that resources, their KPIs and everything. The logs are there, events are there. If you click on a pod list, you can see live usage, CPU usage and everything, memory usage and everything. So, and even you use different thank you, fan. What are some common challenges that are faced to deploy and managing Kubernetes clustering? That's a good question again. Actually, very few, because we have discussed in the start this thing. For me, there are four challenges, or you can say four problem normally people or the organization faces. First is resources, the human resources. The second thing is the complexity. Complexity in terms of Kubernetes is very versatile, dealing different things. So you need some people or some resources which are capable enough to manage all that stuff together. Because even if you are the DevOps guy, or even if you are from the IT world, you need to have some networking knowledge, you need to have some IT knowledge, you need to have some security consideration as well. So that is one option. Second is, as Kubernetes is very much popular nowadays, so there is a more chances of security hacks. Vulnerabilities are there, because that's why CNCF keeps on changing their version. Currently 1.27 is going on. Every time they started deploying some features and everything, like for example, previously you can create pods and every resources. Now you need to be create with some security tokens and everything. So the things are evolving. The more things are famous, the more are they are under attack. So there are some consideration. Thank you. Acha, one question is Kubernetes volume. Volume is nothing but a storage location. And Kubernetes is also managing, or you can say dealing with the volumes. There are thousands of volumes available, types of volumes available. For example, storing data on your laptop is the one of the basic thing. You can use NFS. This is very dedicated topic. Maybe if you can, if you want, we can have one more session for the Kubernetes. So we can do this thing. Otherwise, we will be deploying the third part, which is deploying, sorry, conducting third part, which is specifically for the designing some solution or over different, like we use CCI, maybe we are using another tool other service, CCE, that is managed Kubernetes. So you can do this thing as well. And how volumes are managed by CCI? Yes, you can manage CCI volumes as well. There's an option of storage, and you can use EVS, you can FSS Turbo, and you can create volumes, and then you interact with these volume or the storage location with your deployment and with your resources. But just do one thing, keep in your mind that CCI is the tool which is normally for testing and for small medium enterprises. For higher enterprise and for higher load, you used managed Kubernetes. That is the other resources. Or definitely, uh, the companies normally they don't use one provider or one company. They use mix and match of the solutions. For example, some resources are on the private cloud, some are on the public cloud, some are on vendor one, some are on the vendor two. And that is the beauty and the availability of Kubernetes, that is interacting with everyone. Maybe I have a cluster of 5 nodes, and every 5 node are used or deployed on a different location, different provider, different availability. How does Kubernetes handle application updates and a rollback? Saqib, that's a very good question, but unfortunately, this is very advanced question. You can discuss me alone. That's the problem, but we need to focus one thing. But just a quick thing. Like for example, I have made one changes, very small changing in my file, and then but definitely these changes are not always done on a live. You just make changes and you create images, and then you start deploying one by one. For example, if WhatsApp has created some feature, so they did not go for like they upload this file to the Play Store and everybody start using. They do in a patches. For example, they deploy for some location, then some location, maybe some other sort of like maybe they said like, okay, who wants to join the beta testing? So only dedicated group of people will get that update. So they test this update and then give the feedback. So this is called something about the rollback. But nevertheless, you can come to me if you have any different questions now, which are not related or which are out of the syllabus. You can put a ask for help post. Maybe I or somebody else will answer you, and definitely you will not be uh, still available. You can easily get the answer. So I'll try to answer, or anybody else will the answer. So you will post an answer question in ask for help, and then you get the answer. Thank you, Kimmy. Thank you for the appreciation, everybody, and thank you and everyone. Also the Eid Mubarak who are celebrating today. So, and the best thing and the very important thing, whenever you use the cloud services, always lead the resources, because definitely every resource is being charged. Maybe it's very minimum charges, but what if I multiply this with 1 million seconds, then definitely this is in the USD, then it'll cost you higher. So it's always a good practice to delete resources if it is not in use. So I'll be doing the same thing. And over to you, Miss Alina, if you have to add something. Let me share a screen. And definitely, this is my link. You can find me on LinkedIn. You can find me on the forum, and you can follow me. That's fine. Yes, Miss Alina, over to you.
Okay. Will you share the slides regarding the
Yes,
community?
please.
Thank
Sure,
you.
sure.
Okay, since it's been almost 2 hours now, I'm gonna keep it short. I just want to mention to everyone who might be new to our webinars that this training was presented to you by the Huawei support community, which is the official technical community for Huawei enterprise products, solutions, and certifications. In case you don't have an account yet, I will invite you to join us because as a member of our community, you have access to many different benefits, such as access to free knowledge. For example, you were able to attend this webinar for free, but also many other technical magazines and technical collections that you can learn from. If you are studying or preparing for a Huawei certification, you will also find a lot of useful content in our community. You have an extensive knowledge base that you can learn from if you want to improve your technical skills. And also you can use our community for problem solving. We provide technical solutions within 24 hours. And you can also become a more active member of our community. You can join us as an elite user if you feel like you can share more knowledge with the other members of our community. You can become an elite user and get access to some exclusive benefits. I will also invite you to subscribe to our monthly activities, webinars, because we have different rewards for each of them. The Q&A, the live Q&A, we already had it, right, Baz? We will not take any more questions. I think you answered most of the questions, but in case any of you have any remaining questions, please post them in the community. You can leave a comment here. I shared the link again. So you can leave a comment there. You can ask your questions there in the community. And you can also ask for help posts in the community in case you have some technical issues that you need support with. Let's go to the final slides with the activity, please. Okay, so as I said, we have some activities. First of all, three participants who shared the best questions will be rewarded with 605 points. And since I received some questions earlier regarding how we select the users, please know that the three users are usually selected by the webinar host based on how relevant the questions are. So it's not the number of questions you post, it's the relevance of the questions you post. The questions need to be relevant to the webinar topic. Okay, so this is what I wanted to say first of all. Second of all, the 5 winners who answered the 3 questions correctly will be randomly chosen. So we want to give everyone a fair chance to win. And the only way to do that is by randomly selecting the winners. And as for the 3 best questions, I think that the webinar host is the most qualified person to select the best questions that are relevant for that respective session. Okay, so with that being said, I invite you to go to the community and answer the 3 questions that will be presented. I will also share the questions in the community after we end the live session. The rule is that you need to leave a comment below this post with the 3 correct answers. And as I said, 5 winners will be randomly selected afterwards. Bashir, will you present the 3 questions? Of
Sure.
course, the questions are related to today's topic as well.
Definitely, they are.
Yes.
Yeah. So I just quickly read out this question for you. Kubernetes is a container orchestration system. True or false? You know the answer. Don't try to write over here, please. Just maybe the post is hidden now, Alina, so they can start sharing their response on the post.
Yes, I'm updating the post as you speak.
That's
I
great.
will add
Thank
the
you.
questions, and also please note that the answers will be hidden, just because it's fair not to steal the answers, right? So
Great.
the answers will be hidden and will be unhidden once the activity time ends. Okay.
Great. So second part, second question is, Dash is a serverless container engine that allows to run container without creating and managing serverless cluster. What is this? Options are there: Cloud Container Serverless, Cloud Container Instance, Serverless Service, or Cloud Fusion. You know the answer. The last question is also very easy. Dash are some of Kubernetes resources. Okay. The first one is Fusion, container, static IP, DNS. Second is pod, deployment, config, map, job, secret. Third is none of them. And fourth is all of the above. So all 3 are single answers. And definitely you'll be sharing your response. And and winning some prize.
Okay, so these were the 3 questions. I also shared them in the community, so you can start answering them in the comments. Basically, you need to leave a comment with the correct answers if you want to qualify for the rewards. Thanks again for joining our session today. Looking forward to our next sessions. Once we decide the third session of this cloud native series, we will let you know. We will post in the community as always. So if you don't have an account yet, now is the time to register and become a member of our community to get access to all our special activities, webinars, and so on. So thanks everyone. Thank you, Bashir, especially.
You're welcome.
And I wish everyone a good day or evening ahead based on where you are from. And thanks again, everyone. Goodbye.
Thank you. Goodbye. Thank you.
Bye-bye, everyone.
Bye, everyone.